Hello students, okay, this is our third lecture and I believe we stopped yesterday at question number 5 of matrices. Now let us continue from where we had left. Okay, so now I will continue with the exercise. I think question number 6, 7, 8, 9, 10 are remaining. First of all, I will solve the 3 MCQs which are question number 8, 9, 10. And they are relatively very easy, so we can finish it off very fast. Question number 8 of exercise 4.1. Question is A is equal to Aij m cross n is a square matrix if dash is a square matrix. Therefore, since it is a square matrix, number of rows will be equal to number of columns. So therefore, m is equal to n. So that's the answer. Very simple. That's question number 8. Then, moving forward to question number 9. Two matrices are given as equal and we have to find if values of x and y are possible or not. So question number 9 says, okay, matrix 3x plus 7, y plus 1, 5, 2 minus 3x is equal to 0, y minus 2, 8, 4. This is given. And we have to find this is given in question number 9. And we have to find the values of x and y if they exist or not. So what I will do, yesterday we discussed that by equality of matrices, each and every corresponding elements of the two matrices must be equal. So both of them are 2 cross 2 matrices and they are equal. So we will say the corresponding elements are equal. So 3x plus 7 is 0 and 5 is equal to y minus 2 and y plus 1 is 8 and 2 minus 3x is 4. So what I will do is that now here I will first solve the two equations involving y and I must get same values of y. So here I am having y minus 2 is 5 and y plus 1 is 8. So here I get y is equal to 5 plus 2 7 and y is equal to 8 minus 7. So it is true. Means we are getting the same value of y by solving two different things. So which is true. So here, therefore, y is equal to 7. Now, we will consider the same logic for x. So 3x plus 7 is 0 and 2 minus 3x is 4. So here I end up getting 3x is minus 7 and 3x is 2 minus 4 minus 2. If I solve further, I will get x is equal to minus 7 by 3 and x is equal to minus 2 by 3. So from here, I will end up getting x is equal to minus 7 by 3 and from here I will get x equal to minus 2 by 3. The meaning of and suggests both the values of x must be same or we can select only the common values of x which are appearing. Here we are getting x as minus 7 by 3 and here we are getting x is equal to minus 2 by 3. So I will write it is false. So, no value of x exists here. So even if we are finding y is equal to 7, we cannot get the value of x. So I will come to the conclusion that it is not possible to find x and y. That is the option number 2. So answer is it is not possible find x and y. I hope I'm clear. Not tough, right? Easy. Personally, if someone asks me, question number 10 is, you can say, a very good question for 1 mark. It's a very easy question and very popular question which can come and they can change the way they can ask. I hope this is makes clear and I can rub it off. Okay. And now moving on to question number 10. Question number 10 says, find the number of all possible matrices of order 3 cross 3 with entry 0 and 1. So question number 10 on the exercise 3.1. The number of all possible matrices of order 3 cross 3. Let A is equal to Aij, or I will write let A be 3 cross 3 matrix. Okay, now since it is a 3 cross 3 matrix, it will have 9 elements. So let that be A, B, C, D, E, F, G, H, I, and it's a 3 cross 3 matrix. Since it is a 3 cross 3 matrix, number of elements is equal to number of rows into number of columns. So 3 into 3, 9. So in matrix A, there are 9 elements. And here it is written that each element can be 0 or 1 only. So what I can say is that A can be selected in 2 ways, 0 or 1. B can be selected in 2 ways, 0 or 1. C can be selected in 2 ways, 0 or 1. So each element, each of 9 elements from A to I can be selected in 2 ways. That is out of 0 or 1. I hope I'm clear. So, how many matrices will be possible? Number of matrices possible will be the number of ways in which we can select A, number of ways in which we can select B, number of ways in which we can select C, and till I. So, what I will write is that number of possible matrices A is equal to total number of ways of selecting 9 elements of A. Now, the first element, each element can be selected in 2 ways. So, small a can be selected in 2 ways, B can be selected in 2 ways, C can be selected in 2 ways, C, D, E, F, G, H, I. Each of the 9 elements, I have written over here that each of the 9 elements can be selected in 2 ways. So, total number of ways of selecting the 9 elements of A will be equal to 2 into 2 into 2, 3, 4, 5, 6, 7, 8, 9. So that turns out to be 2 raised to 9. So it is 2 to the 4, 8, 16, 32, 64, 128, 2 is 500. So 500. So total number of required matrices A is equal to 512. That's the answer. That's option number D. So that's easy. Okay. And here we did the multiplication, which It actually involves the fundamental principle of counting of multiplication of permutations and combinations, which we did in 11. So I hope you remember that very well. Now coming to question number, I think 6, 10, 7 were remaining. What I will do is that I will first solve question number 7 and then I will see which question has to be done from question number 6 because it has few 2 or 3 types, 2 or 3 you can say some I've given 2 or 3 sub questions are there all of the same type, but we'll see if I need to solve or no. Okay, now coming to question number 7. Okay, question number 7. Question number 7 says, find the value of A, B, C and D from the equation. Okay, so to be precise, two matrices are given as equal. A minus B is equal to A minus B, 2A minus B, 2A plus C, 3C plus D is equal to minus 1, 5, 0, 13. This is given. And we have to find the values of A and B. So what I will do is that, okay, now since these two matrices are given to equal, I will say that this is 2 cross 2 matrix and this is also 2 cross 2 and both of them are equal. So what I will do is that since two matrices are equal, we will equate the respective elements. So A minus B will be equal to minus 1 and 2A plus C will be equal to 5. 2A minus B will be equal to 0 and 3C plus D will be equal to 13. Did I write the question wrong? So A minus B, 2A plus C, 2A minus B, 3C plus D. Okay. I think I'm right only. So A minus B is minus 1, A minus B is minus 1, 2A plus C is 5, 2A minus B is 0, 3C plus D is 30. Now, I will give this as equation number 1, this as equation number 2, this is equation number 3, this is equation number 4. Now, what I will do is that I will solve first and second. From that, I will get the values of A and B. And once I get the value of A and B, I will put the value of A in second equation. Then I will get C, and once I get C, I will put it in the equation number 4, and I think I will get the value of D. I think very easy, not tough. So first I will solve 1 and 3. So A minus B is minus 1, 2A minus B is 0. This is first, this is third. So just subtract. So what do you end up getting? 1 minus 3. A minus 2A. So it's minus A is minus 1. So A will be 1. Okay, that's easy. Now, A minus B is 0. Sorry, A minus B is minus 1. Therefore, 1 minus B is minus 1. So B is 1 plus 1, 2. So I am getting B as 2. See, now the work is cut out. Now it's very easy. We have found out A and B. So now it's really easy. By 3, I have 2A plus C is equal to 5, and I will put A is equal to 1. So 2 into 1 plus C is 5. So 2 plus C is 5. Therefore C is 3. 5 minus 2, C is 3. And by equation number 4, I am having 3C plus D is 13. I will substitute C as 3, and I think that will give me D. So easy. So 3 into 3 plus D is 13. So 3 3s are 9 plus D is 13. So D is 4. Pretty much easy. A is 1, B is 2, C is 3, D is 4. Let me check the answer. A is 1, B is 2, C is 3, D is 4. Yeah. So we are right. So finally, you just make a note of the final answer which you get, that you end up writing. Therefore, A is 1, B is 2, C is 3, D is 4. I hope pretty much clear, not tough, relatively easy. Okay. Now, just tell me thinking, should I do the question number 6 or not? Because first, second, and third, because it was all the questions from equality of matrices only, and they are relatively easy, I think so. Okay. Okay, now what I will do is that I will solve the second question from it, because I think that is somewhat not tough, but it has some simple basic maths which some students might be finding it difficult. I know no one will be finding it difficult, but let me do just that question only, and the remaining two you can do as homework. So what I will do is that I am solving question number 6 of exercise 3.1, the second question. Okay, what is given? It is given as x plus y, two matrices are given that equal x plus y column wise 5 plus z 2 xy is equal to 6y 2 8. Okay. Now again we have to find the values of the three variables which are appearing. This is a 2 cross 2 matrix. Again, this is a 2 cross 2 matrix. The two matrices are equal, so respective elements are equal. So what I will do is that x plus y is 6 and 2 is equal to, not a big issue, 5 plus z is 5 and xy is equal to 8. Okay, so I will write this as first equation, and then the second equation, and then the third equation. Now what I end up getting, 5 plus z is 5. So what is it? 0. Okay, and remember that I end up getting z as 0. Now we have equation by 1. We have x plus y is equal to 6. So what I will do is that from here I end up getting y as 6 minus 6. This I will write as 4. Put this 4 in 3, which is xy is equal to 8. So x into 6 minus x is 8. So 6x minus x squared is equal to 8. So x squared minus 6x plus 8 is 0. So x squared minus 2x minus 4x plus 8 is 0. Factors of 8 whose sum is 6, 4 2s are minus 4 minus 2. We can do the splitting directly, but it is showing over here because it is the early days of the first chapter. X common, x into minus 2 minus 4, x into minus 2 is 0. Relatively easy. X minus 2, x minus 4. If you can write directly, you can directly write the factorization. So x minus 2 is 0 or x minus 4 is 0. So what is x? So x turns out to be 2 or x turns out to be 4. And by equation number 4 we have y is equal to 6 minus 6. And by 4 we have y is equal to 6 minus 6 and z is 0, which we remember, which we had solved before. So what I will do is that I will take the first case, x is 2, I will find the y and z, and then I will, for x is equal to 4, I will find y and then I will get the answer. So not tough, but just typical simple question. Now x is 2, therefore y is 6 minus 6, 6 minus 2 is 4, therefore y is 4. And what is the answer? X is 2, y is 4, z is 0. That is the first answer. And the second one is, second case is x is 4. Therefore, y is 6 minus x. 6 minus 4 is 2. So y is 2. So ultimately what we end up writing? We get x is 4, y is 2 and z is 0. So these are the two. I I think answers given. The first answer will be x is equal to 2, x is equal to 2, y is 4, z is 0. The second answer is x equal to 4, y is 2, and z is 0. So we are right. So that is the second question of question number 6. You can do the question number 1 and question number 3, sub question of question number 6 of exercise 3.1. So that finishes the exercise 3.1 of matrices chapter, and now we will move on to the next topic, which involves, you can say, the operations involving matrices, means addition, subtraction, multiplication. There is nothing like division in matrices. Okay. So now the next topic is operations on matrices. The next topic is operations on matrices. I hope this was clear, not at all tough, and easily you got it. Now today I will try to cover up around, say, like addition, subtraction, maybe if possible multiplication if it is possible and if I can finish. Okay, you need to go through the videos which I have uploaded, and you need to make the notes on daily basis and revise it, and you can let me know any of the difficulties which you are having. I will try to give you the best possible guidance from my side, and I expect that you also work hard and try to give your best. Okay, now continue. Operations on matrices. Okay, the next is operations on matrices. First is addition of matrices. Now see, in matrices, the two matrices to be added must have the same order. Two matrices to be added must be of same order. Must be of same order. And second point is, you can directly say that sum of two matrices can be obtained. Sum of two matrices can be obtained by adding corresponding elements, by adding corresponding elements of the given two matrices of same order. It's very simple. They need to be of the same order, and then we have to add the respective elements, and that is pretty much clear. So that will be very easy, you can understand. I'll give it. Right. Let A is equal to Aij of the order n cross n, comma B is Bij of the order n cross n. Both the matrices is the same order, n cross n, n cross n. So A plus B is possible. A plus B is defined, as you write, because they have same order. And now what I will do is that A plus B can be obtained by adding the corresponding elements of A and B. So this can be written mathematically as A plus B is equal to Aij of the order n cross n plus Bij of the order n cross n, and you have to add the respective elements. That means Aij plus Bij of the order n cross n. This is A plus B. So A is m cross n, B is m cross n, A plus B will also be m cross n, and it can be obtained by adding the corresponding elements of the two matrices. Okay, I'll consider a simple example. A is 1, 2, 3, 4 and B is 5, 6, 7, 8. So then A plus B will be 1, 2, 3, 4 plus 5, 6, 7, 8. This is 2 cross 2. This is also 2 cross 2. So I am not writing that they are of the same order. 2 cross 2, 2 cross 2, so A plus B is defined. So I am just adding. And now, how A plus B can be obtained? You just have to add the corresponding elements. So I will write A plus B is equal to 1 plus 5, 2 plus 6, 3 plus 7 and 4 plus 8. Pretty simple. See, some students will do it directly, but it's better that when you're doing it starting, you write all the steps. 6, 8, 6, 10, 8, 12. So this is the final answer for A plus B. I think not tough. You want me to give another example? Okay, let me give another example. Okay, A is 1, 2, 3, 4, 5, 6. This is 1, 2, 1, 2, 3. 2 rows, 3 columns. A is and B I will take as -1, -2, -3, -4, -5, -6. 2 rows, 3 columns. So 2 cross 3. So A plus B is defined. A is 2 cross 3, B is 2 cross 3. So A plus B is defined. A plus B is defined. Okay. So A plus B will be 1, 2, 3, 4, 5, 6 plus -1, -2, -3, -4, -5, -6. And then you have to add the respective elements. So what do you end up getting then? Once I add the respective elements, this is 3, this is 2 cross 8, 2 cross 8, that explanation is given. So just you have to add the respective elements. So 1 plus -1, 2 plus -2, 3 plus -3, 4 plus -4, 5 plus -5, 6 plus -6. So what do you end up getting? 0, 0, 0. So you end up getting a 0 matrix. It's an example. So that's the way you can easily solve. So A plus B turns out to be 0, 0, 0, 0, 0, 0, which is O. Which is, you can say something like this: O 2 cross 3, or you can just write 0 matrix of the order 2 cross 3. So this is regarding the addition of 2 matrices. But again, the one more important point which I need to neglect: A is equal to 2, 1, 3, 0. B is equal to 1, 1, 2, 0, 3, 1. Now see, what is strange about these 2 matrices? A is 2 cross 2 and B is 3 cross 2. Means they don't have the same order. They don't have the same order. A is 2 cross 2. B is 1, 2 rows, 3 columns. So 2 cross 3. So therefore I can write A plus B is not defined, because they are not of the same order. So A addition of two matrices is possible only when they have same order. But here A and B have different order, so A plus B is not defined, and such matrices are said to be not compatible for addition. That is, we can say that here A and B are not compatible for addition, as they don't have same order. I hope I'm clear. So I gave you the example of addition of two matrices, and I also gave one example when addition of two matrices is not possible. So that's the first part which we did extra. Okay. Now this is the simple thing for addition of matrices. Now the next topic is multiplication of a matrix by a scalar. Okay. So what I will do is that let A is equal to given matrix Aij of the order n cross n, comma k belongs to R. K is a real number. Here K is a real number. This scalar. That is, it is any real number. Then Ka is equal to matrix of order n cross n obtained by multiplying every element of A by K. Ka is matrix of order n cross n obtained by multiplying matrix of order n cross n obtained by multiplying K to every element of A. Let me write it again over there, don't worry. Ka is matrix obtained by multiplying each element of A, K. That is K belongs to R. And the next point is, and here this Ka is known as multiplication of matrix A by scalar K. Okay, so that is literally very easy. And suppose we just want to write in theoretical way, A is Aij of the order m cross n. K is a scalar, so K is a real number. So Ka will be K times Aij of the order n cross n. So Ka is K multiplied to every element. So K times Aij, and it will be of the order m cross n only. So what I will write is that for K belongs to R and A is equal to Aij of the order n cross n, Ka is of order n cross n, and this is K into A, multiplication of matrix A by a scalar 8. I hope very much clear. But suppose you are having a give me 2 minutes. I'll give 2 examples and you will understand in the most easy way you can. I will try to explain by giving some really simple examples, not 4 or 5, but 2 will be sufficient to understand. So you don't have any doubt. Okay. So give an example. First, let A is equal to simple. I will give 1, 2, 3, 4. Then therefore 2A will be 2A is 2 times, and let matrix say 1, 2, 3, 4. What you do is that multiply 2 with every element. So what I end up getting? 2A. What you get? 2A. Very simple. 2A will be 2, 4, 6, 8. Easy? Here I show this by showing 2 into every element. Now I think from here we can do this directly. Well, I did not do it directly. I did not do it directly because it was the first example. Now let me do it directly for another example. A is equal to 1, 2, 0, minus 1, 4, minus 3. Okay. And suppose they have asked minus 3A. So I will write minus 3 into this matrix. I will write 1, minus 1, 2, 4, 0, minus 3. So I will multiply minus 3 with every element. So minus 3A. What I will do is that just show that step in this question only. So minus 3 into 1, minus 3 into 2, minus 3 into 0, minus 3 into minus 1, minus 3 into 4, minus 3 into minus 3. Okay. So minus 3A will be, no need to look at this directly, minus 3 into 1, minus 3, minus 3 into 2, minus 6, minus 3 into 0, 0, minus 3 into minus 3, 1, sorry, minus 3 into minus 1 is 3, minus 3 into 4, minus 12, and minus 3 into minus 3 is 9. So it's a direct answer. It is easy. No need to do that step. No need to do this. Now I prefer that we will not do those steps. Third example, let me give. Let A is equal to 2, 4, 8, 10, 12, 14, 20, 30, 60. Therefore, suppose they have asked half A. So half A means half times this 2, 10, 20, 4, 12, 30, 8, 14, 60. So what has to be done is that half is to multiply. Now see, it is not nice if I show that multiplying half to every element. There are 9 elements. So it's better we do it directly, and how it is done, let me show you. Half into A will be, okay, 2 into half, 1, 4 into half, it's 2, 8 into half is 4, 10 into half is 5, 12 into half is 6, 14 into half is 7, 20 into half is 10, 30 into half is 15, and 60 into half is 30. So there is a final answer. See, that will be very lengthy if I write half into 2, half into 2, 1, half into 4, 2, half into 8, 4, half into 10, 5, half into 12, 6, half into 14, 7, half into 20, 10, half into 30, 15, half into 60, 30. Simple. No need to do the steps. Means you can avoid this step. Sorry, no need to do the steps, the wrong thing. We have to show the steps, how we get it. Okay. Now, this is, you can say, multiplication of matrix by a scalar. Then comes the important topic. It's not important topic. Another topic. Negative of a matrix. Negative of a matrix. Negative of a matrix. Okay, negative of a matrix. Let A be a given matrix. Let A be a given matrix. Okay. So what I will write is that negative of A is denoted by minus A, and it is actually minus 1 into A. So what is negative of A? It's a matrix obtained by multiplying every element of A with minus 1. What I said, now I will write let A is equal to let A be a given matrix of order n cross n. It's better you write. Okay. Therefore, minus A is negative of A, and minus A is minus 1 into A. So minus A is matrix obtained by multiplying minus 1 to every element of A. Very simple. So minus A, what is minus A? Minus A is minus 1 into A. Minus 1. Minus A is minus 1 into A. And how it is obtained? Minus A, how it is obtained? Matrix obtained by multiplying minus 1 to every element of A. Let me give an example. It's very easy. Now you can do it directly because we have done with matrix multiplication or multiplication of a matrix by a scalar. So it is that only. So for A is equal to Aij of the order n cross n, minus A will be minus 1 into A. So what it will be? It will be minus 1 into Aij of the order n cross n, and minus 1 multiplied to every element. So what I will write? Minus 1 into minus Aij, it turns out to be minus Aij, okay. Minus 1 into Aij cross n. So that will be minus Aij of the order n cross n. That is minus A. This is minus A. What is minus A? Minus of Aij. If A is Aij, minus A will be minus Aij of the order n cross n. Easy? And again I will say two examples. You will understand. So what is minus A? It's negative of A. What is negative of A? It's a matrix minus 1 into A. And what is minus 1 into A? Matrix obtained by multiplying every element of A with minus 1. I think pretty much clear. Personally, I feel you will not be having any doubts. Personally, I feel you will not be having any doubts. Let me give you one or two examples. First, let A is equal to 2, 4, 6, 8, 10, 12. 1, 2, 2 cross 3. I need to write every time, but Okay. There minus a is minus 1 into a. So what is minus a? Minus 1 into 2, 4, 6, 8, 10, 12. See, now what I will do, directly multiply minus 1 with each and every element. So I will end up getting minus 8 as I will get minus a as minus 2, minus 4, minus 6, minus 8, minus 10, minus 12. This is minus 8. For this 8, this is minus 8. Now instead of doing these two steps, what I will do is that I will give one example and I will not show these steps. I will do it directly. Let a is equal to sin theta x minus 1 0. Therefore, minus a is multiplying. See how minus a is obtained. If we have a, minus a can be obtained by multiplying minus 1 with every element of it. So what I did, a is 2, 4, 6, 8, 10, 12. So minus a is multiplying minus 1 with every element. So minus 2, minus 4, minus 6, minus 8, minus 10, minus 12. So a is sin theta x minus 1 0. So minus a means multiplying every element of a with minus 1. So I will multiply each and every element with minus 1. So sin theta becomes minus sin theta, x becomes minus x, minus 1 becomes 1 and 0 remains 0. So this minus directly. You need to show two steps, right? Easy. So that is multiplication. Sorry, that is negative of a. Now, okay, so that is negative of a. Now difference of two matrices. The next operation again is difference of two matrices, and that is subtraction of two matrices. Now see, it's simple. I will not drag it. It is same as addition of a and b. It is same as addition of a and b. But you just have, means during some addition of two matrices, we added corresponding elements. What here we have to do is that we have to do the subtraction of the corresponding elements. I will write difference of two matrices. Okay. Let A is equal to first and foremost, two matrices must be of same order. Two matrices must be of same order. And second point is difference of two matrices can be obtained by let's say in a simple word as given. You just check. Okay, difference can be obtained by taking, by, you can say by subtracting, corresponding elements of two matrices. Please don't get confused by what I have written over there. I just wrote it for those students who suppose they want to make some notes in detail and all. So I have written that. Ultimately, it is very simple. by subtracting corresponding elements of two given matrices of same order. Okay. So, what are the points? So let I will take Aij of the order n cross n. B also has to be the same order, Bij of the order n cross n. Then difference means subtraction. So A minus B is Aij of the order n cross n minus Bij of the order n cross n. What has to be done is that A minus B can be obtained by subtracting the corresponding elements Aij minus Bij of the elements n cross n. Sorry, I said of the order n cross n. So what is A minus B? A minus B is difference of A and B, and A minus B is, if A is Aij, B is Bij, then A minus B is Aij minus Bij. So A minus B is Aij minus Bij. Then subtracting the corresponding elements from each other, you get. I hope it is simple. Let me give, you can say, two simple examples so you will understand. No need to panic, no need to worry. First, A is 1, 2, 3, 4. B is 1, 2, 3, 4, 5, 6. Now see, A is 2 cross 2 matrix, 2 rows, 2 columns, and B has 3 rows, 2 columns, 3 cross 2. So A is 2 cross 2, B is 3 cross 2. Both are not of the same order. So for difference of matrices, A B n cross n and B also n cross n. So for difference of two matrices, they have to be of the same order. So that's why A minus B is not defined as A and B have different. In the first example, that difference of two matrices is not possible. That is the first example which I gave, so that you don't have any doubt. So that's the first part. And now you know I will be giving those matrices only in which the order is same. So directly the subtraction or difference of two matrices can be done or can be taken. Okay, let second example. Sorry. Let A is equal to 1, 2, 3, 4. The 2 cross 2. B will keep at 4, 5, 6, 7. Again it is 2 cross 2. So 2 cross 2, 2 cross 2. So both they are same order. So A minus B is defined. A minus B is defined because A and B are of the same order. So for A minus B, 1, 2, 3, 4 minus 4, 5, 6, 7. So what is A minus B? Just subtract 1 minus 4, 2 minus 5, 3 minus 6, 4 minus 7. You just have to take the corresponding difference. You have to take the difference of the corresponding elements. So 1 and 4 difference, 2 and 5 difference, 3 minus 6, 4 and 7. So that I wrote. So final answer will be A minus B will be 1 minus 4 is minus 3, minus 3, minus 3, minus 3. It's easy. That is A minus B. I hope I'm clear. Not very tough. Not easy and not tough. You can say, why not? I will say not easy because if you do a simple mistake, your answer is wrong. It's easy. But sometimes we get carried away. हम फॉर्म में आ जाएंगे and we don't get the answer. One mistake and final answer was wrong. We got final answer wrong. I think in last lecture, in the previous one or two lectures, I did some mistake and you can remember one answer I got wrong because of not putting proper attention in the calculations. You need to be very, very, very proper while solving the sums. Okay, now give me another example. We give another example. A is, take 3, 0, 4, 6, and B as 2, you can say -2, 4, 0, 1. Okay, I put it minus. A minus B. A is 2 cross 2. B is also 2 cross 2. So A minus B is defined. So A minus B will be 3, 4, 0, 6 minus 2, 0, 4, minus 1. And then, okay, don't do this directly. It's like two more steps. 3 minus of minus 2, 0 minus 4, 4 minus 0, 6 minus of minus 1. So what do you end up getting? A minus B, you end up getting as 3 plus 2, 0 minus 4, 4 minus 0, and 6 plus 1. And now see, this I will prefer what you must get this answer directly without doing these two steps. 3 minus or minus, so 3 plus 2, 5. 0 minus of 4, so minus 4. 4 minus 0, 4. And 6 minus or minus 1, so 6 plus 1, 7. So from here I got 3 plus 2, 5, 0 minus 4, minus 4, 4 minus 0, 4, 6 plus 1, 7. But what I want you all to do is that from here you must get this diagram. You must develop the method to not do these two steps. These two steps must be avoided. These two steps must be avoided. See, you can do from here to here, you will get it definitely once you practice more and more and more. Obviously, for the first 2 or 3 times, you have to write this, then you write this, then you write this, then this, and then. Now, with some students, what they do, they will write this, and finally, after 2 or 3 sums, they will prefer to write this directly. That is also not a problem. Okay, no problem. So, that is the difference of two matrices. Now, moving on to the next topic, which is properties of matrix addition, and you can say difference also. So properties of matrix addition, relatively easy, not at all tough. It involves the, you can say, the commutative law, the associative law, and one or two things: existence of identity and additive identity. I mean, and existence of additive inverse, or you can say negative of it, which you already know it indirectly, but it will be clear to all of you within 5 to 10 minutes once I write this way. Okay, properties of matrix addition. Properties of matrix addition. Now see, properties of matrix addition, it has a commutative law, then associative law. Now what is commutative law and associative law? I will just write it, and you just need to remember it. It's very simple. First is commutative law. Okay, commutative law. What it states: A is equal to Aij of the order n cross n, and B is equal to Bij of the order n cross n. If these two are given matrices of same order, then A plus B is equal to B plus A is commutative law. That you know. in addition of two numbers. A plus b is b plus a, or x plus y is equal to y plus x. Same way, a plus b is equal to b plus a, but they need to be of the same order. So a plus b is equal to b plus a is the commutative law. So what is the commutative law for addition? What is commutative law for addition of matrices? A and b are matrices of the same order. Then a plus b is equal to b plus a. Then the second is associative. Second is associative law. Now, again here, I will write for associative law we need three matrices. So let they be of the same order. We can say here let A is equal to Aij of the order n cross n, B is equal to Bij of the order n cross n, C is equal to Cij of the order n cross n. Then the associative law is A plus B plus C is equal to A plus B plus C is associative law. So what is associative law? For addition of matrices A plus B plus C is equal to A plus B plus C. So that is the commutative law and that is the associative law. What I will do is that directly I will write note करके first A plus B is equal to B plus A, commutative law. And the second point is A plus B plus C is equal to A plus B plus C is the associative. Simple. इतना ही याद रखना है. Not tough. A plus B is equal to B plus A. Commutative law. A plus B plus C is A plus B plus C. Associative law. I hope I'm clear. And what you can write is that here the three matrices involved. Here there are A and B, and here there are A, B, comma C. So what you write is that make it a point that A, B, C are, you can say, matrices of same order. So I will write A, B, C are here. A, B, C have same order. Means they can be added. They are compatible for addition, or they are, you can say, the addition is possible. So that is what is the commutative law and the associative law. And now the third one. For the third one, what I will do is that I will just give an example, and then I will write. I'll give two examples to be precise. Right. For the third one, it is additive existence of additive identity. Now see what has to be done. I'll give first an example. Let A is equal to 1, 2, 3, 4. 2 cross 2 it is. And consider null matrix O of the same order 2 cross 2. O, zero matrix, or you can say null matrix. Sorry, I will use the word null matrix or zero matrix. Actually, zero matrix is also known as null matrix. I forgot to mention about it yesterday. Okay. A is 1, 2, 3, 4. It's a 2 cross 2 matrix. So O, the zero matrix will be 0, 0, 0, 0. Again, it's a 2 cross 2 matrix. Now, sorry, A plus O will be 1, 2, 3, 4 plus 0, 0, 0, 0. What do you end up getting? Adding the respective elements. A plus O will give me 1 plus 0, 1, 2 plus 0, 2, 3 plus 0, 3, 4 plus 0, 4. What do I end up getting? A only. So, A plus O is A. Similarly, O plus A is A. This is, I think, obvious to you. You know it. but if I have written it directly, it would not have been clear to many students. So the point is, we just need to write. We just need to write. Ultimately, let A is equal to Aij of the order n cross n, and consider zero matrix O where all the elements are 0 of the order n cross n. Then A plus O is equal to O plus A. Therefore, A plus O is equal to O plus A is equal to A. Therefore, O is equal to additive identity. For matrices. Additive identity. I hope I'm clear. Not tough. I could have written this directly, but this, after giving you an example, this becomes much more easy to understand and explain. So A plus O is equal to 0 plus A is A, and O is additive identity. That is the third property of matrix. Similarly, there is another one, fourth property of matrix addition, which is existence of additive inverse. Existence of additive inverse. Okay, now let me put it in a way. I'll give you an example. Let A is equal to similarly one example 1, 2, 3, 4. So definitely you know minus A is, what is minus A? Minus A we did today. After finishing off that exercise, I have explained minus A is actually negative of A. What is negative of A? It is obtained, minus A is actually minus 1 into A. So minus A will be, minus A is obtained by multiplying every element of A with minus 1. So minus A is actually multiply every element of A with minus 1. So 1 into minus 1 is minus 1, minus 2, minus 3, minus 4. So this is A, this is minus A. And if I add them, you know what you will end up getting? A plus minus A will give me what? Yes, majority of you know it. Personally, I think all of you know it. A plus minus A will be, I'll write this like that, 1, 2, 3, 4 plus minus 1, minus 2, minus 3, minus 4, and that will turn out to be. Now see, I will not write directly, I will not show the step 1 plus minus 1 and all. 1 plus minus 1 is 0, 2 plus minus 2 is 0, 3 plus minus 3 is 0, 4 plus minus 4 is 0. What is this? It's actually zero matrix of the order 2 cross 2. So I can write, I am getting O, 2 cross 2. So here, what I got? A plus minus A. I got A plus minus A as O. Similarly, minus A plus A will be O. This thing is actually the law which I want to say. So A plus minus A will be minus A plus A will be null matrix. This is the thing which is obvious for you. Means A plus minus A gives me the additive identity, minus A plus A gives me the additive identity. Therefore, minus A is called additive inverse of A, or minus A is called negative of A. So what I will write is that for A is equal to Aij of the order n cross n, minus A we know is minus of Aij of the order n cross n. Therefore, A plus minus A will be equal to minus A plus A. A equal to minus A plus A, and that will be equal to O. So minus A is equal to additive inverse of A. Additive inverse of A. So that is the existence of additive inverse. This is the fourth properties of matrix addition. So what I will put it in a very simple way, as I had written the two laws, the commutative law and associative law, after writing them in detail, means just wrote it. I will sum up what is existence of additive inverse and what is existence of additive identity. So what I will write is that directly you have to remember only the main step, just one line. You have to remember that first A plus O is equal to O plus A is A. Therefore, O is additive identity. Okay. And second point is A plus minus A is minus A plus A is O. So therefore, minus A is called additive inverse of A. I think this way we can sum up the last two properties, and I think this much here is enough for today for you to understand and revise. So I think I will end the note. I will end the lecture here. This is the third one and fourth one. These two are the, you can say, the last two properties of matrix addition. Just revise it properly and make notes of it daily. I will upload this lecture by maybe within 1 or 2 hours, or maybe by late night, and then you can refer it tonight or maybe tomorrow morning. So you finish all the notes and study well and practice it daily. Okay, thank you and study.